Alright, welcome to Quadratic and Radical Equations. What I'll first do is talk about a standard quadratic and then get into what happens later in this section of quadratics and radicals of different forms. This is a quadratic equation. It generally will have three terms. It does not have to. We have our square term or quadratic term, our linear term, and then a constant term. To solve an equation that's set up like this, we're going to have two basic techniques. One is to solve by factoring, and the second is the quadratic formula. The good news is they both have this similar feature in both those techniques, is no matter what, you need to get one side of the equation set equal to 0. So what I'm going to do is I'm going to subtract 24 from both sides of this equation right now. The result of that will be x squared minus 2x minus 24 equals 0. Okay, and again I mentioned there's two ways of solving this standard form quadratic. There's going to be factoring or the quadratic formula. I think factoring is a lot better because it's quicker. If you're really good at factoring especially, you can solve these really quick. So what I'm going to do now in solve by factoring is now that I have one side of this equation set equal to 0, it means I've moved everything interesting over to one side. Doesn't matter if it's the left or the right. What I'm going to do is now factor this quadratic, a technique that we've learned previously. And I won't go through that, but you could verify that this factors into x minus 6, x plus 4. Just a quick review on that. Those two numbers, negative 6 and 4, multiply to be negative 24, and they add to be the negative 2. Okay. Here we go. If we have it set equal to 0, we factor the non-zero side, and then what we can do is simply we're going to set each of these factors equal to 0. This is called the zero factor property. So I'm going to do x minus 6 equals 0, or x plus 4 equals 0. If you're wondering why we could do that, I could go into a detail, and there's some videos in the homework that describe it more, but the basic point is that if either this factor or this factor equals 0, it doesn't matter what the other one is. When they multiply together, we're going to get out 0. And again, that's called the zero factor property. You can look that up in a textbook, or you can search for zero factor property on Google for more information. And what we do now, we're pretty much done. We're just going to solve each of these two equations. We're going to get two solutions. Actually, we're always going to expect two solutions from quadratics. Just a side note, actually the degree of the equation will tell you how many possible unique solutions you have. This is a degree 2 equation, and so this could have two unique solutions, which it does, of 6 and negative 4. And you could test that. I won't show that right now. You could test by plugging those values back in for x here and see if that all works out to be 24 after you square and then multiply by 2 and subtract. That's called solving by factoring. And this could be easier or harder depending on how hard it is to factor the non-zero side. All right, let's now get into the fun of these quadratic and radical equations. We now have two very basic equations that I'll go through quickly and then show more difficult examples. So in each of these cases, we're going to apply the concept that a square root and a power of 2, or squaring, cancel each other out. On this left-hand side, I'm going to apply the square root to both sides of this equation. The square root has the effect of canceling out this square, and so I'm just left with x over here. On the right-hand side, the square root of 25 is just 5. Okay, now we're actually getting our first issue with these problems, is that this problem actually has two solutions. 5 is the first one, but as spoken before, I suggested there could be two unique solutions. There doesn't have to be, but there often is, or usually. There is a second solution to this, and it's negative 5. Because squaring cancels the idea of a negative, because negative 5 times negative 5 is 25, this is actually the second solution. So there becomes an issue right away when we use a square root. We don't get both solutions naturally, so what we need to do, and let me show you this done a different way, we need to introduce this idea of this non-positive or this negative solution, to be specific. I'm going to take the square root of both sides of this equation. When I do that, what I'm going to do is get x equals 5, but I'm going to add this symbol plus and minus in front. This is actually the shorthand for this solution set above of 5 and -5. So this plus or minus 5 is just a shorthand quick way of writing 5 and -5. Every time I take this or apply a square root to an equation, I have to get this plus or minus 5 on the non-variable side, on the number side. Another way of saying it. Okay, so that's we apply the square root to get rid of the square, but it's kind of messy, but that's the trick to fix it. That's the only trick when we apply a square root. We're going to have an opposite issue. It won't show up here, but it will in a second. On the second side, what I'm going to do is square both sides of this equation. When I square this, I get rid of the square root because they are opposite operations. And so what I will get is x equals 49. Now, there are not two solutions. This is actually the only unique solution, the only solution at all to this equation. There were no issues with that. We're done. But I just want to mention, and we'll show it in a second, there is something strange about squaring, and it happens to be in some strange way the opposite of what we do here. Again, when we take the square root, we don't get both the solutions we should have, so we need to manufacture it, make that happen. What happens over here, I'll just give you, and then we'll look at it in a second, is you could possibly create fake solutions. We call them extraneous solutions when you raise stuff to the second power. Let's do some more complicated problems and you can see this play out. All right, here we go. So let me show you quickly how that same logic plays out here. On the left-hand side, I have something squared. This is a quadratic equation. I'm going to apply the square root to both sides. When I do that, I just get rid of this square here on the left-hand side to get x plus 3 equals 4. But you're probably yelling out now, hey, what about that plus minus? Heck yeah, we're actually going to add the plus minus in here so we get both of our possible unique solutions. Now this is strange though, because now I have x plus 3 equals plus or minus 4. Not just x equals plus or minus 4. This plus 3 is kind of strange. How do we deal with that? It's not a big deal at all, actually. What I'm going to do is write out both the equations that I'm expressing right here. This is x plus 3. Oops, excuse me. Let's change to black. X plus 3 equals 4. Or x plus 3 could equal -4. That's what this above statement is saying, these two separate solutions or equations. So let's solve this first one. It's pretty easy. This one just gives me x equals 1. Or if I solve this one, I get x equals -7. So these are our two unique solutions that we would expect. We only got two solutions because we implemented this plus or minus thing right here. I would recommend, I won't go through it just to keep this video short, but I would recommend if you're thinking that is a strange way of solving and why, specifically why is this -7 allowed, plug these values back in for x to this original equation one at a time and convince yourself that they both work. And you should see why the x equals -7 works as a solution. All right, let's deal with the albatross in the room, which is going on the right-hand side right here. This is going to have, again, it's kind of the same issue that we get in having to implement this plus minus, but the completely opposite. The hint from before was we actually maybe get these fake solutions when we do this, and this one will show us that. But let's square both sides. Again, that's the same thing we're always going to do. We square in order to get rid of this square root. So that's what it does on the left-hand side. What we're going to get over there is just x plus 14. Over here, when we take x plus 8 squared and we square all of that, don't forget what we're actually doing when we do that is x plus 8 times x plus 8. Whenever we square a binomial, we have to do this foiling or this double distribution, however you want to think about it. And we get x squared plus 16x plus 64. You just have to trust me. You could do it on the side here just to verify that's true. That becomes now, by the way, this is a quadratic. So we're dealing with a radical that now becomes a quadratic. What I'm going to do is set this equal to 0. I won't write it out, but what I'm going to do is subtract x from both sides and then subtract 14. Basically, this one side over here that has less, I'm going to move that over to the right-hand side by subtracting it away here. If I subtract x from both sides, what I'm going to get now are just 15 x's over here. If I subtract 14 from both sides, I'm going to get a 50. I'm setting this equal to 0 because I'm going to implement that previous example of solving by factoring, and I'll factor this very, very quickly, and you can pause it if you need to verify that I'm not screwing anything up here. Okay, here we are. I've got two solutions, x equals -5 and x equals -10. Let's look at those two solutions real quick. I'm going to clean everything up here real fast. I'm just going to go back to that original equations and look at these two solutions. Just address this last concept in this section as far as what we call extraneous solutions. All right, let's get back to it. Real quick, what I want to do is just check these solutions. What I'm going to do, always when you check the solutions for equation, I'm not going to interact both sides in any way. I'm just going to plug in my values and work them down. If it is a solution, the right-hand side should equal the left-hand side. So let's just check this real fast. If I plug in a -5 up here, I'll get -5 plus 14, all under the square root over here. And then on the right-hand side, I get -5 plus 8. And let's just do this math. -5 and 14 would be 9. So this is the square root of 9. And over here I get 3. And this actually verifies that this works because the square root of 9 is 3. So this, and I could go down to this stage right here. That really verifies it. That's true. X equals -5 is a solution to this equation. Let's plug in the -10 now. Again, I did everything right. There was nothing wrong with the process that I used, but let's just make sure I get both these solutions here. So -10 plus 4 is 4, so this is the square root of 4. Nothing is strange there. -10 plus 8 is -2. So this is actually an issue. Here, what I got is the square root of 4 is 2, but on the right-hand side I got a -2. This means that x equals -10 is definitely not a solution. It came out as a solution when I did my work. I did everything correct. I raised everything to the second power. I set everything equal to 0. I factored. I got these two solutions. The issue is whenever I raise an equation actually to any even exponent, it's possible to create extraneous or fake solutions. That is the one thing to be aware of. So in summary, what I'm going to do is when I apply a square root, I need to use a plus or minus every single time to get to the two possible, the positive and the negative possible solutions. When I have a radical equation and I use an even exponent, I'm going to do everything and just put my head down and work it down. But I always have to check my solutions just to make sure I don't have any extraneous solutions.